Our learning objective here is that we want to talk about that when we have more than one sample, we want to see what's going to happen, right? We want to know that, for example, what's going to be the confidence interval when we have more than one sample. Because in reality, what's happening is that we're having like a few samples and we compare them together, right? So when we say that confidence interval, or we say hypothesis tests, so what's going to happen if we have like more than one? We're going to have the same cases, like case 1, 2, 3, 4. Case 1 was that when our parameter of interest was mean, the variance was known. And case 2 was that when the parameter of interest was mean again, but the variance of the population was unknown. Case 3, the parameter of interest was sigma, and the case 4 was the parameter of interest was proportion. So in this video, as our learning objective is that we want to construct confidence interval and also develop the hypothesis test on the difference on the means for two samples. So it's like that you have two, let's say you are working in the lab, you get the data for two different samples or two different populations, and then you want to compare them together. So we want to talk about, see that what's going to be the difference between them, what would be the hypothesis test for it. So for hypothesis test, we said that we have 8 steps, right? Step number 1 was that, okay, construct the, let me know what's your parameter of interest. So we are in case 1, the parameter of interest is mu, and variance is known. Then it was like we would say, okay, so now we know the parameter of interest. Step 2 was that what would be the null hypothesis. So for the null hypothesis, we would say that mu1 minus mu2 means that from the first sample and the second sample, or first population and second population, the difference between them is like we would say delta null. And then the alternative hypothesis, if it's two-sided test, it's going to be mu1 minus mu2 is not equal to delta null. If it's one-sided test, which would be like mu1 minus mu2 greater than some data, some value, and or the delta mu1 minus mu2 is less than some value like delta null. So this is H null and H1, like the null and alternative hypothesis. And then these are our 3 steps. Then we said that, okay, so we want to see that what would be our test statistic, right? So for the test statistic, when we are working with the two samples, the parameter of it, with case 1 of the two samples, so the test statistic is going to be this. So it's going to be, look at here, it's very similar to the time that we had like one sample. So when we had one sample, the test statistic was x bar minus mu divided by the standard error, which was over there, it was sigma over a square root of n. So here it's very similar. Look, it's very interesting. Like x1 bar minus x bar 2, right? And then minus this delta null is like that is mu1 minus mu2. So we have like x bar here and we have mu here, right? Like whatever we have for x bar minus like negative, whatever we have for mu. And this is our standard error. So for a standard error, previously in case 1 of the one sample, it was sigma over a square root of n, right? So I'm going to write down here as a side note, like just as a side note. And we have a video on this, right? So it's like that. We would say case 1, and then I have one sample. So we said that the standard error, it was sigma over the square root of n. I can write down it's equal to the square root for total of that, and then here it's going to be sigma 2 over n. So now look at here, it's very similar. It's interesting. So here is the sigma, because we have two samples, or two population. Sigma 1 square divided by n1 plus sigma 2 square divided by n2. So it's like that. It's like you're adding one more data after one more sample over to this one. So that's our test statistic. So our knowing what would be the test statistic, then we said that, okay, in step number 5, we want to choose an alternative and choose a proper level of significance, which was alpha. Like for example, if you are looking for the 95% confidence interval, alpha is going to be 5%. If you're looking for the 90% confidence interval, so alpha is going to be 10%. So we are going to find out the alpha, and then after alpha is going to be, we're going to talk about the rejection region. So rejection region is the part that, for example, if we are in the rejection region at the end, it means that we reject the null hypothesis. If we are not in the rejection region, we are going to fail to reject the null hypothesis. So I'm going to use the opportunity and show it to you here. Let's say we have two-sided tests, and here it was the z of the half of the alpha and z half of the at half of the alpha, but here it's going to be negative, right? Because here it's 0. So what's going to happen is that we said that whatever we have in this area, here is my null hypothesis. Like the null hypothesis is that, for example, this difference is in this area. The alternative hypothesis is the time that we are in this area and this area. So rejection region is going to be whenever you are at this. So these are rejection region. Depending that if when you want to make your conclusion, you are working with the z or you're working with p-value, you would go, okay, so I'm going to work with this region or I'm going to just work with this line. So what would we say for the rejection region? We would say that if our z of the observation, so the z that we find from the test statistic is z null or let's say z observed. So if my z of the observation is less than this area, like for example, if it was here, so if it were here, this is just, I'm assuming, right? If my z of the observed, it was in this area, or if it was in this area, in that case, I would say I would reject the null hypothesis. So if here is going to be half of the z for the test statistic that we found. But if we are in the, depending that if we are in the rejection region or not at the end, when we want to make conclusion on step number 8, we would say that we are going to reject the null hypothesis or fail to reject the null hypothesis. So now let me just write this. Okay. So we have the, let's review it quickly. Parameter of interest, null hypothesis, alternative hypothesis, test statistic, alpha is equal to some number, and then the rejection region. So I have to count it again. It should be very in the step number 6, right? Yeah. So number 7 is that we are going to do the computation. So whatever, like for example, I'm going to put the data points here and find out the value for it. If we are going with the z approach, if you are going with the p-value approach, what we are going to do here is that when we find out the z null, we would need to go and find out, we need to go to the z table and find out the alpha related, like regarding this z null, z of the observed. So we would say that then that's our p-value. And then we compare the p-value with the alpha. But we would do whatever computation that we have, and then we make the conclusion that we would we fail to reject the null hypothesis or we reject the null hypothesis. So now that's for the hypothesis testing. So that's the approach that we use for the hypothesis testing. Hypothesis test and the confidence intervals are very related. So when we look at this, let me see if I can red or blue. I have the blue one, hopefully, or red one. Okay, so we said that this one was like x bar minus mu divided by whatever we have in the denominator. We are going to call it a standard error. So let me just have this one here like this. So this one is a standard error. So when we decide on when we find that this is a standard error, then finding out the confidence interval is going to be very simple. So for the confidence interval, we said that basically the thing happen is this. I get the value of the x bars from the sample, right? And then I want to say, interpret something for like or predict something for the population. So what I'm going to do, I would say that this estimate from the sample plus minus some margin of error is going to be the interval for the population. So here I'm going to write down like this. Based on this, for the confidence interval, so this part was the hypothesis one. This part that I'm going to write down, we are going to construct the confidence interval. So I'm going to write down here, construct confidence interval. So for constructing the confidence interval, what I will do is that I would say mu1 minus mu2, right? That's the parameter of interest. The parameter of interest is the difference between the mu and we know the variance. So it's going to be between two bounds. So here we are going to have x bar 1 minus x bar 2, right? And here I'm going to have x bar 1 minus x bar 2 as well. The thing happened is that, again, it's very similar to the time that we have one cases. So when we had one sample in case 1, when we had one sample, we would say x bar plus margin of error and x bar minus margin of error. So here I have the same things, x1 bar minus x2 bar plus my margin of error, right? And then here I would have x bar 1 minus x bar 2 minus margin of error. So now the margin of error for this case, or I can write it down like margin of error like this. It's going to be, think about it for a moment. If I ask you for the margin of error, what would you write? It's two-sided. What would you write down? You can pause the video, try to think about it. For one case, it was, for one sample, for case 1, it was z times standard error. So here it's going to be the same. So I would have the z at half of the alpha because it's two-sided, right? This is two-sided. So I'm going to write down it's two-sided. So z at half of the alpha, and then times this standard error that we have. So it's going to be times sigma 1 power 2 n1 plus sigma 2 power 2 n2. So I'm going to put this one here or here. So that's going to be my confidence interval. If it was one-sided, what would happen is that we would have like mu1 minus mu2 less than x bar 1 minus x bar 2 plus z at alpha. And the rest was the same. The standard error was the same for the upper bound. If it was lower confidence interval, so you would say, when it's lower confidence interval means that you don't look at this one. You're going to remove it. And here we would say x1 bar minus x bar like 2, x bar 1 minus x bar 2, minus, instead of margin of error, I would write down z at alpha and times the standard error. So the standard error is the same. So in this video, we have learned about how can we develop the hypothesis test, as well as the confidence interval for case 1 when we have more than one sample, when we have like 2 samples or 2 populations and we want to compare them together.